Hello everyone. This video is on the Knewton Alta assignment, section 2.2, part 4, titled Parallel and Perpendicular Lines. In this video I'm going to go over a preview version of this Knewton Alta assignment. Please understand that the questions I see in this video may or may not be exactly the same as what you see when you work on the assignment on your own. But the objectives will all be the same, so the questions I see should be similar to what you see. So I'm hoping that watching me do these will help you in some way, when you're working on it on your own. Alright, so here's your assignment page. Again, you won't see the words preview of, you'll just see the title. Got your mastery bar, right, telling you how far along you've gotten. You can see the objectives and how far you've gotten in those. Looks like there are 3 objectives in this particular assignment. Beneath the current objective is a question related to that objective. And at the bottom of every question, there should be a feedback button where you can send feedback to Knewton about issues you're having with the questions or typos or something. You will not see this instructor cheat button, right? This is only for instructors. But you will see this more instruction button, which you can click on when you're having trouble with a particular objective or a question, and it will send you to a page with some reading to do or some videos related to that topic. And then you'll have questions related to that instruction. And getting those questions right still moves you through the assignment. So you can complete the entire assignment by hitting the more instruction button every time you get a new question. Nothing wrong with that. Okay, so this first question is on the objective, given the equations of 2 lines, determine whether the graphs are parallel or perpendicular. Alright, so before I actually get into this, let me talk about what it means for 2 lines to be parallel and 2 lines to be perpendicular. So first let me talk about parallel lines. Now 2 lines are parallel when they don't intersect and they run in the same direction on the same plane. So a very quick picture and very rough picture of a couple parallel lines would be like this. Say a line going in this direction here, and then another line goes in the same direction but doesn't touch the first line. Now some notation you might see, maybe these little arrow marks on a couple lines to indicate that they are parallel. But the thing you're going to need to know about parallel lines, though, for this particular assignment is that parallel lines, they have the same slope, right? They have equal slopes and different y-intercepts. Or x-intercepts as well, just different intercepts really. So if the slope of this line was say m1, and the slope of this other line was m2, then you have m1 equal to m2, right? And again, their intercepts must be different. So if this was, the y-intercept here was b1, and the y-intercept here is b2, b1 is not the same as b2. All right, remember, for y equals mx plus b, the slope-intercept form. Because if they had the same slope and same intercept, they'd be the same line and they wouldn't be parallel. They'd be right on top of each other. They wouldn't be, they'd be intersecting everywhere. Parallel lines don't intersect, and they run along the same direction, the same plane. Okay. So the key is going to be slopes. Right. Now, perpendicular lines, a little different. Perpendicular lines, two lines are perpendicular if they intersect at a right angle. Right? So they can't just intersect. Right? Like these lines here aren't perpendicular that I just drew. The way they intersect is wrong. Is not a right angle, 90-degree angle. So they intersect. Right? They cross each other at a right angle. Right? Or a 90-degree angle, same thing. So again, a very rough sketch here. Let me move this paper out of here so you can't see the background. Another rough. Now, I mean, the x and y axis are perpendicular, right? So that's one case. You're going to have, a horizontal line and a vertical line are perpendicular. That's like, case one. If you have a horizontal line and a vertical line, they are perpendicular. Right? If one's horizontal, one's vertical, they're going to meet at a 90-degree angle. All right. So that's one case. But not every line is horizontal. Not every pair of perpendicular lines is horizontal and vertical. I mean, we could have a line like this, and then another line that meets it at a 90-degree angle, say here. And again, I'm just drawing a rough sketch here, but there's a where they meet is a 90-degree angle. I'm making the little right angle box there. Now, how do you tell without, just looking at them? How do you tell with an equation with the slopes and all that? How do you tell that two lines are perpendicular? So say the slope of this line that I drew is m1, and the slope of this other line that I drew that's perpendicular to it is m2. This is the second case. Right? The product of the slopes, right? The product of the slopes. So if you multiply the slopes, product of the slopes of perpendicular lines is always -1. So if I took m1 and multiplied by m2, I would get -1. Now, some other people might say this, right? This is equivalent to the following. The slopes of perpendicular lines are opposite reciprocals, or negative reciprocals. You may see those words. Right? When you multiply reciprocals, you get 1, right? +1. 1/2 times 2. Those are reciprocals, and they multiply to be 1. But when you multiply opposite reciprocals, you get -1. So for example, 4/5 and negative 5/4. Right? They're reciprocals, but opposites as well. They're positive and negative. Right? You flip it over, make one positive, make one negative, and align two lines with these slopes. Two lines with these slopes would be perpendicular. Now, if the product of their slopes is not -1, then they're not perpendicular. Right? So if I have some line with a slope of 2 and another line with a slope of -2, those multiply to be -4. That's not -1, right? They're not perpendicular. And again, the first case, remember horizontal lines have a slope of 0, vertical lines have a slope that's undefined, so you can't really talk about their product. That's why I have a whole separate case for that, right? Okay. All right, so this is what we're looking out for. Parallel lines, same slope, different intercepts. Perpendicular lines, they're either a horizontal line and a vertical line, or the product of their slopes is -1. So keep that stuff in mind. All right, so the question we're given, we're given the equation of a line. X plus 6y equals 3. And it asks us to determine the slope of a line that is perpendicular to this line. So first we need to know the slope of this line. All right, so I'm going to find the slope of this line first. Well, you can do that in a couple ways. One is you can find a couple ordered pairs, just find a couple points. Some points on this line. If I made a little table, I'll just make some ordered pairs. If x were 3 and y were 0, all right, that'd be the x-intercept. That'd be on here. If y were 1 and x were -1, so -1, 1, right? -3. -3 for x, my apologies. If x were -3, -3 plus 6, 6 times 1 is 3. So -3, 1. And then I find the slope by using the slope formula, right? Change in y, 1 minus 0 in the numerator, divided by the change in x, -3 minus 3. And then that's 1 over -6. That's -1/6, right? So that's the slope of this line. The slope of any perpendicular line to this, right? Any perpendicular line would be the opposite reciprocal of -1/6. So that means, take the opposite, being +1/6, and then do the reciprocal, which would be 6 over 1. And this is what they're asking us for. All right, so if you were to graph this line and draw any other line with a slope of 6, they'd meet at a 90-degree angle. All right. Now, another way you could have done the slope here, instead of finding 2 points and then using the slope formula, you could also, right, or just put this in slope-intercept form. All right, y equals mx plus b. And remember that the coefficient of x will be the slope of the line. So here I would subtract x, right, get 6, but basically just solve for y to get in slope-intercept form, right? 6y equals -x plus 3, and then I divide everything by 6. Y equals -1/6 x plus 1/2, right, if I divide everything by 6. And there's your slope, right? The coefficient of x here, -1/6. There's m, which I already showed you earlier, right? So it really depends on what you like doing better. I'd prefer it though if you did the slope-intercept form, because you'll find it'll make things a lot easier for later in the later examples. But yeah, so if any line has a slope of 6, it would be perpendicular to this line. All right, let me show you. I'm going to show you a little picture of this. On that, there's a free online graphing calculator website, desmos.com. So I'm going to put in the equation they gave us, right? It was x plus 6y equals 3. Right, there's that line. It's got 0, 1/2, right? And 3, 0, I said was on that earlier, right? Now what I'm going to do here is put in any line with a slope of 6. So y equals 6x plus b. All right, and then I'm just going to add a slider for b. And here's when b is 1. Y equals 6x plus 1. All right, you see the y-intercept is 0, 1. And hopefully you can see, if I zoom in close enough, maybe you can tell that these meet at a 90-degree angle. And if I change b around, it's still meeting this line at a 90-degree angle. All right, let me just go back to the home. See, if I just change b, hit play, that graph, no matter what it is, no matter what b is perpendicular to the original graph that we were given. Right. Meeting at a 90-degree angle. Right. Good. But yeah, so all they wanted though was the slope of any perpendicular line, which would be 6, positive 6. All right, and then after every question, there should be an answer explanation. Please read through these, whether you're right or wrong, because either way, you should be able to understand why you got something right or why you got something wrong, and that way you can, fix mistakes in the future. And maybe even if you're right and they do something a different way than you did and you like it better, you can try that out in the future as well. But it's always beneficial to kind of glance over these answer explanations. All right, next question. This objective here is write the equation of a line parallel to a given line. Now I'm hoping that you've already gone over section 2.2 part 3, where we wrote the equations of lines, right? To write the equation of a line, you need to know the slope of that line and a point that's on that line. All right, so here we're asked to find the equation of the line passing through the point 2, -8, which is parallel to the line y equals -5x plus 5, right? And I'll write this information out. Not the whole sentence, but so our line has the point 2, -8 on it, and is parallel to the line y equals -5x plus 5. All right, and I'll draw a little rough sketch of the situation here. So 2, -8. This point is on our line. Y equals -5x plus 5, that has a y-intercept of 5. So 0, 5, and a slope of -5. Meaning if I go to the right 1, I have to go down 5, right? So 1, 0 would be on that line. So here's the line they gave us, right? This is the line that they talk about here. This is, right, that's y equals -5x plus 5. Our line is this line here, right? It passes through the point 2, -8 and is parallel to that line, right? So like this. Right. There's our line, right? And we need to know the equation for that. Right. Remember, parallel means runs in the same direction without touching, right? Well, I have a point. Now I just need the slope. Well, the slope of this line, I'll call it M1, is -5. Right, the slope is -5 for that green line I drew, the first line. And since we're parallel to it, the slope of our line, which I'll call just M2, or how about just M, right? The slope of our line, M, is -5. It's got to have the same slope. And you see it has the same slope, different intercepts. All right, now I go to point slope form. Again, I'm not going to go over all the forms of linear equations or how to write equations again. Go back to section 2.2 part 3 for that stuff. The equation of this line in point slope form would be the following. Right, using this point, this slope, would be y minus negative 8, or y plus 8. Right, y minus the y coordinate of the point I know, equals the slope of the line, which is negative 5, times the quantity, and then x minus 2, x minus the x coordinate of the point. But then we're asked to put this in slope-intercept form, so I distribute the negative 5 here. We solve for y. Y plus 8 equals negative 5x plus 10, and then I would subtract 8. Y equals negative 5x plus 2. There's the equation of this orange line I drew. Alright, so that means my drawing's pretty rough, actually, because like it should be crossing the y-axis at 2. It looks like negative 2 almost, but let me show you a better picture of this. Alright, again, I'll go to that Desmos website. Let's clear this stuff out. Alright, so the equation they gave us was this one, y equals negative 5x plus 5. And the equation I ended up writing, that's, the one that passes through the point 2, negative 8, and is parallel to this, would be negative 5x plus 2. Alright, so you see they're parallel. I'm hoping you see that they're parallel, clearly. And let's just make sure that the point 2, negative 8 is on that second line. So I put the point 2, comma, negative 8. Maybe we'll label it and see that it's on the black line. Look at that. Right? So there's our line going through 2, negative 8 and parallel to the line, that purple line they gave us. So the equation I wrote is correct. So then down here, y equals negative 5x plus 2. Great. Again, please read through the answer explanations. Next. Alright, so we're back to the objective about determining whether graphs are parallel or perpendicular. Alright, so are the graphs parallel, perpendicular, or neither? I mean, you can have two lines that just cross each other, but not at a 90-degree angle. So they wouldn't be parallel, they wouldn't be perpendicular at all. Right? So yeah, that's why I suggested, put these in slope-intercept form. It'll be much easier to see if they're parallel, perpendicular, or neither if you have the equations in slope-intercept form. Right. Okay, so the two equations, the two lines were given. First one's x plus 2y equals 2. When I put this in slope-intercept form, be y equals, I would subtract x and then divide everything by 2, so it'd be negative 1/2 x plus 1. And then the other equation we were given, 2x minus y equals negative 3. Here I would just add 3, add y. We have y equals 2x plus 3. Alright, so I'll call the slope of this line slope 1. M1 is negative 1/2. And the slope of this second line, slope 2, M2, equals positive 2. And hey, these are those opposite reciprocals, right? If you take negative 1/2 times positive 2, that's negative 1. These are opposite reciprocals, telling me that the lines are perpendicular. And you can go to that Desmos website or some graphing calculator and you can see for yourself. I'm going to leave that one to you, but you'll see for yourself that these two lines meet at a 90-degree angle, a right angle. Right. So perpendicular, submit. Hooray. Alright, moving on. Alright, so back to that parallel one again, writing the equation of a line parallel to a given line. Alright, so just flipping this over. Alright, so the point that our line passes through is 1, 3. And we're told that our line is parallel to this line. y equals negative x minus 2. Now the slope of this line, which I'll call m1, is negative 1, right? This is already in y equals mx plus b form. It's already in slope-intercept form. So the coefficient of x is the slope. So that means the slope of our line, which I'll just call straight up m, is negative 1 as well, right? Since they are parallel, they should have the same slope. So now I have a point, I have the slope. I can start off writing the equation in that point slope form, y minus 3 equals negative 1 times the quantity x minus 1. Distribute the negative 1, got y minus 3 equals negative x plus 1, and then add 3, y equals negative x plus 4. Alright, and again, these are parallel lines. They both have the same slope, different intercepts, right? Negative 2 and positive 4. And this line I put the box around has the point 1, 3 on it, right? The x and y coordinate 1, 3 would satisfy that equation. So that should be good. And again, you can go to Desmos, you can go to some graphing calculator and look at it and see for yourself. But I'll leave that to you this time. Now notice they already have the y equals part, so I'm just entering the other side. Negative x plus 4. Good. Alright, now continue on. Alright, so this is the other objective we haven't seen yet. Write the equation of a line perpendicular to a given line. So this is very similar to the last problem I just did, but instead of the word parallel, right, you got the word perpendicular. So you just have to remember what that means when it comes to slopes. Alright, so I'll keep this same page up here. So let's go to the bottom half. So we're told, the line we're trying to write an equation for is 2, negative 9. Right? This point is on our line. And we're also told that our line is perpendicular to the following. The line y equals negative x over 2 minus 4. Now the slope of this line is negative 1/2, right? The coefficient of x is negative 1/2. So remember, the opposite reciprocal of this would be positive 2. Right? You take positive 1/2 and then flip it. So the slope of our line, because of, again, perpendicular, would be positive 2. Opposite reciprocals. They multiply to be negative 1. And now I can use this information to write the equation of our line in slope. And they want it in slope-intercept form, right? They got y equals, and then we have to fill in the other side. So y plus 9, right? Y minus negative 9 equals the slope 2 times the quantity x minus the x coordinate, x minus 2. So y plus 9 equals 2x minus 4. Then I would subtract 9. Y equals 2x minus 13. Alright, and let me actually draw this one out. I'll go to Desmos for this one because we haven't seen this objective yet. Let's verify this. Alright, so we were given this equation, y equals negative x divided by 2 minus 4. And the equation I ended up writing at the end was y equals 2x minus 13. And hopefully you can see, you can zoom in or whatever, but these do meet at a right angle. These are perpendicular lines. And I'm hoping also that the point 2, negative 9 shows up. I'm just going to plot that point. There it is. Look at that. 2, negative 9 is on this line that I drew that is perpendicular to the first one. Great. All right. Okay, so we fill in y equals, and then what I had was 2x minus 13. Great. Oh, they're calling it negative reciprocal. I call it opposite reciprocal, same thing. Alright, and then the same objective. So find the equation of the line through the point -8, 8. That is perpendicular to y equals x divided by 4 minus 5. So write that information out. So the point -8, 8 is on our line, and we're perpendicular to this symbol I just drew. It's kind of like an upside down T, means perpendicular. Perpendicular to y equals x divided by 4 minus 5. Now the slope of this line is 1/4, right? The number attached to x is 1/4. So because we're perpendicular, right, the slope, we do the opposite reciprocal or negative reciprocal of this. The slope of our line would be, negative 1/4, but flipped over, negative 4. Okay, and then we'll use that information. The slope is negative 4, passes through the point -8, 8 to write an equation. So in point slope form, that'd be y minus 8 equals negative 4 times x plus 8, quantity x minus negative 8x plus 8. So y minus 8 equals distributing the negative 4 here, negative 4x minus 32, and then adding 8, y equals negative 4 times x, and negative 32 plus 8 would be negative 24. And there we go. And again, I'll leave the checking on these to you. All right, so there I got the y equals there. So I'm just going negative 4x minus 24. Great. Alright, so now we're here just to find the slope of a line that's parallel. I'm not even going to write this one out. This line is in slope-intercept form that they're given to us. The slope is negative 3/2. So that would be the slope of any line parallel to it, right? Any parallel line should have the same slope. So I'm just typing negative 3/2. Negative 3/2. Very easy, that one. Alright, same objective there. And once again, it's just what would be the slope of a line perpendicular to this line. Again, I'm not even going to write this one out. Just talk it out. This line, this equation is already in slope-intercept form, so I can tell you the slope of this line right now. It's negative 5/6. The slope of any line perpendicular to this line would have a slope that's the opposite reciprocal, which would be positive 6/5. And if you multiply these two slopes, it would be negative 1. Right? The product of slopes of perpendicular lines is always negative 1. Great. Alright, so that objective's done. Now we're just going to be writing some more equations. Alright, so our line passes through the point -1, 7 and is parallel to this line. So this line has a slope of 8. It's already in slope-intercept form. This has a slope of 8. So our line is going to have a slope of 8. So it's going to be y equals 8x plus something. So if I put in the x coordinate, 8 times -1 is -8. And then you think negative 8 plus what would be 7, positive 7. That'd be 15. So I could actually do this right now. Y equals negative 8x and then plus 15 to get me to, when I replace x with -1, or sorry, not negative 8x. I said 8 earlier, right? 8x plus 15, right? And 8 times -1 is -8 plus 15 is 7. That point would be on it. Great. Now you could also do what I did earlier. Put it in point slope form first, then solve for y, simplify. But this is another way to do it, right? Just think about y equals mx plus b. What would, if m is 8 and I replace x with -1, what would b have to be so that y would be 7? Right. All right. And if you want to write all that out, that's fine. I'm sorry I did it in my head here, but yeah. All right, and this one's pretty similar. All right. Passes to the point 7, 2, parallel to this line. This line has a slope of -3. So that means our line has a slope of -3. So it's going to be y equals, I can start it off, -3x and then plus something. Now let's think. When I replace x with 7, you'd have y equals -21. What would I have to add to get y to be 2? -21 plus 23 would be 2. All right, so it would be y equals -3x plus 23. Great, so that one's done. And perpendicular this time. Again, I've already done a couple of these on paper, so I'm probably just going to talk this one out. Alright, so the point -4, 5 is on our line. Our line is perpendicular to this line. This is in slope-intercept form. The slope is 1/4, positive 1/4. So the slope of our line would be -4, the opposite reciprocal. So I know the equation in slope-intercept form for our line is going to start off y equals -4x and then plus something or minus something. So let's think. If I replace x, I want the point -4, 5 to be on this. If I replace x with -4, this would be positive 16. What would I have to do to make that positive 5? Well, I'd have to subtract 11. Right, 16 minus 11 is 5. So y equals -4x minus 11 should be the right one. Yeah. All right, and then the final question, unless I get it wrong. Right, remember, if you get things wrong, the progress bar backs up and you have to do more. Same thing, it passes through this point and it's perpendicular to this line. Now this line, again, this is already in slope-intercept form, so I know the slope right away. It's positive 1/2. So the slope of our line would be -2. So I know that my equation starts off y equals -2x plus something. Now I'd like the point 8, -7 to be on this equation, satisfy this equation. So when x is 8, right? When x is 8, this would be -16. But I want y to be -7. -16 plus what would be -7? Well, -16 plus 9 would be -7, right? Again, you can write that out if you want, but just kind of doing things mentally right now, I'm sorry. Right, there you go. -16 plus 9, -7, cool. Has a slope that's, the opposite reciprocal of this slope. Their slopes multiply to be -1. They are perpendicular. Great. All right. And again, please read through your answer explanations. All right, and that should be it for this preview version of this assignment. As I mentioned at the top of the video, the questions I saw in this video may not be the same exact questions you see when you're working on the assignment yourself, but all the objectives are the same. All right, so the questions should be similar. So I'm hoping that watching me go through these examples here help you in some way when you work on the assignment on your own. And thank you very much for watching.